Welcome to the new unit, Rational Expressions and Equations. So the first thing we're going to be doing is simplifying rational expressions. And another name for rational is, I know you're waiting for it, fractions. So rational and fractions, it's basically the same thing. Anything you can write as a fraction is a rational expression. So what we're going to be doing is we're simplifying. So just as a reminder as to how to do this, you look at these basic examples with just basically things we've done already. You have 13 over 52. If you want to reduce that, you can think of it as, and I'm just going to do this in a way that makes it so that you can see what we're doing later. You can factor these, and if I do this as 13 times 4, you see the 13s cancel out. They divide out is what it really is. We're really dividing 13 by 13 and 13 into 52. Okay, it's the same thing, but we write it like this sometimes so that we can, see the factors that we're actually dividing. Okay, so here, remember, anything divided by itself is 1, so those factors are the same, they cancel out. We've got a 2 up here, and this is a 1 there, so we're left with 3x in the top over 5. Okay, so what are we doing? We reduce fractions by finding a common factor in both the numerator and the denominator. So it's a common factor. And divide, or we use the word cancel even though it's really not what we're doing, cancel from both. So as you can see here for this example, you have an x in the top, a factor of x, and a factor of x in the bottom. So those can be reduced out, and we're just left with x plus 4 over 2. For this particular one, though, x plus 4 is a factor, and I can't break that down. I can't factor that, so x plus 4 cannot be broken. We think of the plus sign, I think Mr. Murray says this, as the marriage, or whatever. They're loved, and they can never be separated. Okay? When I divide it by 2, that 2 would have to go in the x and the 4, and it doesn't, so x plus 4 over 2 is as much as we can do for this. Okay, so now the real stuff. How can we possibly reduce these? Well, we do what we did in the first one. We factor. Change color here. So when you factor, this becomes x plus 3, x minus 3 on the top. This one's already factored. And you'll see that a common factor. So this whole parentheses is a factor. So this one and this one are the same. Anything divided by itself is 1, so technically that's 1 there. And we're just left with x minus 3 over x plus 4. Okay, so this one, so we're going to factor the top, factor the bottom. Now remember, you should know how to factor this. So that's that factored. And then the bottom, 3x plus 2, x minus 1. And you'll notice that 3x plus 2 is a factor for both of them, and you're left with 2x minus 5 over x minus 1. You need review on how to factor things like that? Come see me after school. So basically how we simplify rational expressions is we factor the numerator and the denominator, or top and bottom. Okay, and then we reduce common factors, or we divide, we cancel, however you want to say it to yourself. Okay, that's what's happening. So that's it. Problem that comes up here is that this is basically an easy thing, but there are a few things that happen that we have to watch out for. The first one is the black hole. If you divide by 0 ever, so this is a division problem. If you're looking here, this is line right here means divide. Okay, so when we're dividing, you can never do 0 on the bottom, ever. 0 divided by anything is bad. You remember with geometry, you had a 0 on the bottom, the slope was undefined. It's the same idea. We want to find we can't allow anything in the denominator to be 0. So if I ever ask for excluded values or what values make the fraction undefined, you are simply going to find the values that would make the denominator 0. So sometimes we use the words undefined and sometimes we use excluded values. So all we do is take the denominator. When we ask this question, all we care about is the denominator. And we set that equal to 0. Oh, look at that. We've been solving these forever and kind of sick of it, actually. So this is x plus 3, x plus 2 equals 0. We t-chart those guys, and we're left with, I'm going to do this because I ran out of room there. So x equals negative 3, and x equals negative 2. If we were to take negative 2 and plug it into this problem, we would get a 0 in the denominator. And that 0 in the denominator, we would cause it to be undefined, so we must exclude it. So negative 3 and negative 2 are our excluded values. Excuse me. If you want to think about that as the domain, with a problem like this, the domain is everything except negative 3 and negative 2. It's an interesting graph. If you want to look at it on the graph, you'll see that negative 2 and negative 3, they have some fancy things happening there. Okay, opposite sign factors. So what this means is when you have, say I factor this, and we factor it correctly, okay, the 25 is first, so make sure the 5 goes first here. And we factor the bottom. You'll notice that these look so close. I want them to work. They need to be the same, but they are not the same. Their signs are opposite. So this 5 right here, I'm going to make it an arrow. This 5 right here is positive. This 5 right here is negative. This sign right here is negative, and this x is positive. So the signs are opposite. And basically what that means is I can cancel them out. Thank goodness. Okay, but they factor to a negative 1. Instead of 1, where they were exactly the same, x, if they were both x minus 5, it would just reduce to 1. But since they're opposite sign factors, they reduce to negative 1. So we would just do negative 1, 5 plus x, over x plus 2. So you can distribute that in if you want, but that's a perfectly wonderful answer. So the rule is, if you have opposite sign factors, they reduce to negative 1. And I usually put the negative 1 on the top, but remember it's just the top. You don't put it in both spots. So notice it's only on the top. I wouldn't put it in the bottom also. Okay, share is fair. We discussed this already a little bit, but the basic idea is if I don't have any factors, if I can't factor this or factor this, we're done. Okay, 3x squared plus 5 over x squared. Neither one of those can be factors. And remember, I can't divide the x squared into that 5 also. So I can't factor, so nothing can happen. Same deal here. I can't divide. I can't just cancel out the 14 and the 2x because that 2x needs to go into this negative 17 also. So this one can't be factored either. So just be careful. Make sure you factor first, and if it's a minus sign or a plus sign, they're in love. You cannot break them up. All right, have a great day.